Okay, this is the second video for Chapter 6. I'm going to finish up the cognitive biases, the last three. The first of the three is uh, implicit gender race bias. Now, what I want to emphasize is that there's plenty of explicit gender race bias in the world. So people who, if you ask them, they just think that, people from certain racial groups are, suck, or, men who are just explicitly sexist about women. They think women aren't as good at whatever, right? So there's plenty of explicit stuff. That is not the topic of this bias. This is implicit bias. So these are biases that you can find and you can detect in what decisions people make that the people themselves aren't aware of, but they still do have this effect. So roughly, it's a bias that manifests as a differential assessment of ability, skill, or competence of someone based on race or gender. Or I'll just say potentially other irrelevant factors. So this shows up in a lot of cases like age, socioeconomic background, all sorts of things that people can have an implicit bias about. Most of the examples I'm going to talk about are gender, maybe a few race. I'm not going to really talk about any of the other sorts of things. But if you follow up on this, you'll find that similar results similar to the ones I'm going to talk about show up in all sorts of cases. So here's a key study. There was a recruiting company. So a lot of times big corporations may not always do their own hiring, or they may not do their initial stages of trying to find candidates. Instead, they will go to recruiting companies, which are companies that just get resumes from loads of people. And if, company X says, hey, we want to hire, a bunch of whatever, middle management people or something, sales people, they'll go and they'll just get 100 resumes from this recruiting company. So there was a recruiting company that decided to do a study. And so they sent resumes to many hundred, I think it was like 500 or 1,000, but there's a lot of hiring managers at different corporations, people that would do hiring. And they asked these hiring managers to rate on the basis of this resume how hireable the applicant was. They actually asked several questions. How likely is it that you would want to interview this applicant? How qualified is the applicant? How hireable is the applicant? Things like that. Now, the thing is that the resumes were identical, except that some had a male name and some had a female name, right? So they would send 500 versions of this resume with a male name to 500 hiring managers. Then they would send 500 versions with a female name to 500 different managers. Okay, and then they would just get the results back. And what they found was that on average, the resumes with male names were rated as more hireable. Now the results are actually more complicated. This was the overall finding. There were a few exceptions. Interestingly, for nonprofit companies, that was not the case. In fact, if I remember the study correctly, I think women were rated slightly better than men by nonprofit companies. But the overall thrust was definitely that the male names were just rated better. This happens not only with people like in the business world, but it even happens with science faculty. Again, I pointed this out in the last video. Scientists tend to think that they're super rational and beyond fallacies and cognitive biases, but they're not. So this is a good randomized double-blind study, and it's basically the same kind of format as the one I just talked about, except that the fake resumes are going to science faculty who are hiring people to be laboratory managers. Okay, and they were asked to rate these resumes, and again, rate them on different scales, like how qualified is this person, how likely would you be to interview them, what would the starting salary be, and so on. And what they found is that faculty, on average, rated the male applicant as significantly more competent and hireable than the female applicant, even though it was identical, the identical resume. Participants also selected a higher starting salary, offered more career mentoring to the male applicant. Now here's here's an interesting thing, which is that the gender of the faculty participants, the people who are actually rating the resumes and making the hiring decisions, didn't matter. So it wasn't just that men were rating the men more highly than women. Female faculty were also doing exactly the same thing. They were also biased against women. So this is something I pointed out early on in the first video, which is that not only are these biases implicit, meaning that people aren't aware of the fact that they have them. They're, yes, there are plenty of people who are explicitly gender biased and sexist and racist and whatever, but these participants, probably most of them, are not explicitly biased. In fact, some of them, especially maybe some of the women, were feminist, were pro-feminism and advancing, helping women advance in the field and stuff like that. If you just ask them, they would probably sincerely say, yes, I'm a feminist. I think women, are treated unfairly and we need to make more opportunities for women. They would say all that stuff, but they would still subconsciously exhibit these biases. Okay. Here's another example. It turns out that so major symphonies and orchestras, when they fill a position, right, they need a new clarinet or whatever, they'll have auditions. Someone will come in, they'll play, they'll give them a couple pieces to play, and then the conductor and maybe the some other people involved in the symphony will listen and they'll make a choice about who to hire based on hearing these auditions. Now, for these major symphonies, for most of the history of symphonies, it happened exactly the way I just described. If people wanted to audition for the part, they were, told, okay, practice, here's a passage, here's a piece, show up at this day and time at this location and you'll play it and we'll listen. Okay. There was a shift, though, to doing blind auditions at a certain point. Where a blind audition is where the people who would come in and play would play behind a screen so that the people making the assessment wouldn't know if the person, anything about the person playing other than the sound of their playing, right? How they could hear, but that's it. So they wouldn't know if it was the race of the person, whether it was a man or a woman, how old they were, anything like that. Now, what this in this publication, Golden and Rouse, what they found was that as soon as they started using this screen, the number of women who were selected out of the preliminary rounds increased by 50%. And the screen also enhanced by several fold. That's what they said, and actually if you read the article, it's hard to get more detail on what that means. But it means by at least double the likelihood that a female contestant would be the winner in the final round to get the position. Now, as we know from Chapter 5 in the false cause fallacy, we can't we can't go from correlation to causation, right? Excuse me. So the fact that at the same time the blind reviews were implemented, it also turned out that more women were being selected. It doesn't immediately follow that that's the reason that more women were being selected. Okay, could be there was a common cause. It's probably not coincidence because the number of data points they were looking at is very large. But there, at least based on what I've said so far, there wasn't anything ruling out a common cause or something like that. This study, if you actually read the paper, it's really interesting. They they sort of do a lot of very sophisticated statistical analyses and using other types of data, and they show that in fact a lot of the increase, like 50 some percent or so, like a big chunk of that increase, can definitely be attributed to a causal effect of the fact that they were using the blind auditions. And it's sophisticated analysis that they do, but the original study does go beyond just correlation to causation. So they're not committing a false cause fallacy when you look at the original article. Now here's an interesting tidbit. So this Moss-Rakusen study, this is the one I mentioned up here. This is where the science faculty were given resumes of lab managers and then asked to rate how good those managers were. That was used in a further study, so that showed that there was kind of there was definitely a implicit gender bias in the people who were making these hiring decisions. That study was used in a further study. So this is on the topic of how these biases can interact. So this Moss-Rakusen study showed it had a certain methodology. There were resumes. They were only the name was changed from a prototypically male name to prototypically female name. Otherwise, it was identical. It was given to a certain number of faculty. Here's how they rated them. So the study methodology is there. Okay. What they did was then another study was done. So they took the abstract of this study that showed this bias, and then they showed that same study to scientists who judge how good scientific work is. Okay. And scientists do this all the time, right? You look at an abstract for a study and you assess, yeah, that looks like it was a well-run study, or it looks like it was not a well-run study, based on various factors. So scientists were shown this study and asked to rate how good is the research. And this was the original abstract they were shown. This is basically, they were actually shown more than this, but this is what I read earlier. This was the original study. And they were just asked, okay, how good was this study? Here's what they found. Men rated the quality of the abstract. Oh, by the way, before I get to that. They created two versions of this. Okay, so the real study had exactly this methodology, and it had a certain finding. The finding was that male applicants were rated as more competent than female applicants. They also created a version of the abstract that was exactly the same methodology, but that reported that they found no difference. Okay, so there were two versions of the abstract. There's the real version, which in fact showed that there was a bias. But then there was a version they created for purpose of the study, which was fake, that purported to show no bias. But everything was the same, right? Okay, so just two versions of this study. And then scientists were, different scientists were shown different versions of this, and then just asked to rate how good was this study. Men rated, so male scientists, rated the quality of the abstract less favorably than did women in both samples. Okay. The gender gap is especially large, suggesting evidence a bias might threaten. Wait. Yeah. So, and what both samples means is both versions of it. So if, but let's focus on the real version. Okay. Men who were assessing the quality of the research that showed that there was a bias against women, they judged that study to not be as good. Women who looked at that study judged that study to actually be pretty good. Okay, so they're interpreting the results. When reading these results, a male scientist might think, oh my gosh, if we're going to fix this equality issue, that almost necessarily means that there's going to be fewer opportunities for men, said Ian Handley, who is the lead author of the paper. So here's actually the results of this. So there were two versions of the paper. The blue is what really happened, right? It was a study, and it actually showed that there was a bias for men. Okay, that women were being unfairly assessed, and men were being, basically assessed more highly, even if they didn't really earn it. Okay, there was another version that purported to show no bias, exactly the same study, but that the fake result was yes, and it didn't really matter if it was a male or female name. The applicants were always rated the same. And this is how women versus men rated the two studies. So if female scientists who were given the study that showed that there was a bias against women thought that that was good research, or at least better than the research that showed no bias. Okay, so this is a sort of example of the confirmation bias in effect. So even though the two studies were identical, the only difference was the result, but the quality of the research, how the research was conducted, was exactly the same in both versions of the abstract. Women who will explicitly believe that there is bias against women, so even if they have implicit gender bias, explicitly, if you ask them, generally speaking, women are more aware of the fact that there's gender bias than men are aware of it, right? So women thought that the study that showed that there was a bias was better than the study that showed that there was no bias. Again, because women probably had a prior belief to the effect that there is a bias, and so they rated that more highly. Men had the opposite pattern. They thought that the research that showed there was no bias, that was better research than the one that showed that there was bias. Now, one thing I want to point out here is that both groups are wrong. Okay, if either one of these groups was correct, they should have rated them the same because it was the same scientific abstract both times. Okay, so the correct answer here is equal, right? Because it was the same abstract. So both men and women showed a confirmation bias towards which version of the study they thought was actually a better run scientific study. Now, there is one thing that women are correct about, though, which is the prior belief that they're trying to confirm. So women are right that there is gender bias in the world, okay? And men, if they think there isn't, they're wrong about that. So there is something going on here that women are correct about and men are incorrect about. But these assessments isn't it. Both groups are wrong about these assessments. Okay, let's move on to the Dunning-Kruger effect. Here's a rough definition. The Dunning-Kruger effect, it's a tendency for those who are less competent in some task. That could be anything, and we'll get examples, but good at math, good at playing tennis, knowledge about, how good of a speller you are, whatever, how good you are at fixing appliances, it doesn't matter. But it's a tendency for those who are less competent to judge that they are actually more competent than they really are. And it's also sometimes a tendency for people who are very competent to judge that they're less competent than they really are. Okay, so here's one of the key studies. So this was done on college students, and they were given some tests on their humor. I don't know how they did a humor test, but how good they are at understanding jokes or getting certain kinds of humor, grammar, logic, things like that. So there were different domains that they were tested in. And then not only were they tested, but they were asked to assess their own ability. Okay. Not only were you tested on how well you could get certain kinds of jokes or whatever, however they did the humor test, but people were asked, how good is your sense of humor? How good are you at grammar? How good are you at logical thinking? What they found was that people in the lowest quartile, so the bottom 25%, the bottom quarter of all people, so the 25% who scored the worst on these tests, massively overestimated their performance. So even though their average was the 12th percentile, the average of the bottom 25% was 12%, all right, makes sense. That was their average. On average, they estimated themselves to be in the 62nd percentile. So they estimated themselves to be better than 62% of everybody else. Paradoxically, when you improve their skills, so you take the same people and then you would give them more training in grammar or more training in logic. So they're actually getting better at the task than they were initially. They would start rating their own abilities lower, right? So even though they know they're learning more about the domain, their assessment of how much they know goes down. Okay, so here's a graph. So this was the humor chart. And so here we're just assessing 4 different groups. This is the bottom quartile. So as you can see, this is their actual ability, which is way down here, right? They were like, worse than, on average, worse than 88% of the people. But they thought they were way up here. Okay, the second quartile was a lot better than the first quartile, but their assessment was about the same. The third quartile, they were pretty close to being accurate with their self-assessment. They were here and they thought they were there. But if you look at the top people, okay, they're actually up here at like 90% on average, but they would have self-assessed down here to like 72. You get a similar pattern. That's a little bit different with grammar. So pretty much everyone thinks they're the same. Everyone thinks they're at about 70%, regardless of where they actually are. So again, bottom, middle, third, and highest quartile. This is logic. Here, with the logic, as people learn more initially, they actually go down, which is pretty funny. The bottom quartile people are here. The people who know more actually realize they know less. The third quartile people drop even more. It's not until you get to the really, really good people that their assessment goes up, but it's still less than their actual competence. Okay, here's another study. So this was done with medical residents, junior medical officers in their first postgraduate year. So, and among the things that happens in this first year is they're trained on how to do various medical procedures like draw blood and stuff like that. So all of these subjects completed a questionnaire concerning their confidence and experience in performing these clinical skills. Okay, and I forget how many. I think there were 4 or 6 clinical skills that they were assessing. 7, there we go. Common practical clinical skills. So they were given a questionnaire that asked them about their assessment, self-assessment on these skills. Okay, then they actually really assessed their skill. So the instructors would watch them do this study, and they would be assessed for how good they really were. And comparisons were made between these subjects' self-reported levels of confidence and their instructors' assessments. So even though the first-year students, they would demonstrate a broad range of actual competence levels, right? There were some that were bad, some that were in the middle, some that were really good. Some performed great, some were inadequate. There is no relation between their self-reported level of confidence and their actual performance. Okay, so here are the results. This is for drawing blood, actually sort of getting the needle in and doing a good job of getting a blood draw. So the gray bar is their self-report, their confidence, how good they think they are. The black bar is how competent they really are. And there were 4 different categories that they could fall in. So the worst category was not yet confident, or they're not competent to do this procedure unsupervised. They're just not very good at it. The second group is they're fairly confident or competent. They can do it unsupervised. Then genuinely competent. And then the last group was they're so good that they could even teach the procedure themselves. People self-report, they all thought they were here. There were a couple people who put themselves in the third group, but almost all of them put themselves in this group here. Like, they all thought that they just had it down so well that they could even teach it to other people. But in fact, only a few people were really that good. Most people were in the first 2 groups, right? So basically what this means is that pretty much almost all of these people thought they were here. Get a similar effect for doing a blood culture. Almost everybody thought they were here, but it turns out there were really 2 groups. There was, about half of the people were there, but the other half were really like super incompetent. Some real world manifestations. This is so one way this manifests is in how a lot of people think that they're getting treated unfairly or screwed over by their bosses or people who assess them, right? So for instance, if I think I'm really good, but supervisors aren't promoting me or teachers aren't giving me an A on my assignments, then the one explanation for that fact is that they don't like me, right? Or they're threatened by me. My teachers don't recognize my genius. Because if I'm really bad, I might think I'm really good. Well, of course, if I'm really good, then I should be getting promotions, or I should be getting A's on my papers. So the only explanation for why I'm not getting an A on my papers or why I'm not getting promoted is that there's some sort of they've got a personal beef with me. They're incompetent. They just want me to regurgitate what I heard in class. They don't want me to think originally. And people have all kinds of explanations for this. Notice also how this interacts with the confirmation bias. So if you're subject to the Dunning-Kruger effect, you're really bad at some domain, but you think you're great. That will bias how you interpret data. So if you get a grade back on a paper that's a C, but you think you're an A student, or you don't get a raise, or you don't get a promotion where you work, even though you think you're like the best, employee at whatever you do, making tacos or whatever your job is, working in a medical facility drawing blood. So if you already believe that you're great, then if a piece of data comes in to the effect that you're not great, like you got a C in a paper or you didn't get a promotion at your job, then you will interpret that piece of data in a certain kind of way. You won't interpret it as data that you're actually not as good as you thought you were. Because of the confirmation bias, you'll be more likely to interpret it as, oh, these people don't like me, or they're threatened by me, or something like that. It also manifests in political extremism. So a lot of political positions, policies, are actually very complex, and economic systems and political systems are very complex systems, and most interventions you can do are going to have a lot of effects that have some positive and negative things that are hard to predict what will happen. But people who, this is from a Fernbach 2013, they found that people who hold extreme political attitudes, so far left, far right, or some extreme positions, they hypothesized that those people typically know less about these policies than they think they do. Okay, and that the polarized attitudes are enabled by simplistic models. Okay, so the idea is that if you don't really know a whole lot about how these sorts of policies work, or how the effects of these policies, you have a very simplistic model. You're more likely, excuse me, to think that your model is correct, that the way you're thinking about it is right, that you're an expert and everyone else is an idiot. And that's more likely to make you have an extreme political position. Now, what they found was that if you ask people to explain the policies in detail, so you find someone who has an extreme political position, they think they know more than everybody else does about it, that if you disagree with them, it's because you're an idiot. If you ask them to explain the policy in detail, that helped undermine the illusion of explanatory depth. Okay, so people would start to realize, if you asked them to explain the policy, they would start to realize that they didn't know as much, and led to attitudes that were more moderate. They would then become less extreme once they realized that they didn't really understand the position very well. Now, what's interesting is that this effect only occurred when people were asked to generate a mechanistic explanation. And what that means is like, well, explain to me how exactly, if there's a flat tax, that will help create more jobs, right? Go through the process. And people would say, well, if there's a flat tax, that means that this group will have more money and they will do this with that money, and then that thing will cause this other thing to happen. So you ask people to explain the mechanism by which a policy will have a certain effect. That's what this mechanistic explanation means. If you ask for that, then people would start to realize that they didn't really understand super well how these policies work. But if you just ask them why they believed their policy, oh, why do you think it should be a flat tax? That didn't have any effect. And I think the idea here is that people have reasons that they're happy to trot out as to why they have an extreme political view, even if they don't really understand how that view works or how this policy actually functions. So the way to get them to realize that they're more extreme than they should be isn't to ask them why they have the belief. It's to ask them to explain in detail why this policy that they're in favor of, how it's going to work. That's the thing that gets people to realize that they're more extreme than they should be. They say, finally, this is the same study, asking people to generate mechanistic explanations reduced donations to political advocacy groups. So what that means is that when people were really extreme and they thought that they were know-it-all, they were know-it-alls and they thought everyone else was an idiot, they were more likely to donate to advocacy groups that were sort of hell-bent on that policy, right? Whereas once they realized that they knew less than they thought they did, or that the policies are actually more complex, they were less likely to donate to those groups, because now they weren't 100, they weren't as sure before which policy is right. If you don't know what policy is right, or if you're less sure that you know which policy is right, you're going to be less likely to give your money to a group that's, polarized one way or another. Okay, and now the last bias. Now this is, I'm going to sort of combine two things here in a way that's, I think is legit, but it's not, if people who know all of this research really well would sort of insist that these are two different effects and whatever. But I think that to a first approximation, there's a deep connection here between these. So this is the Knob effect and what's sometimes called the attribution bias or primary attribution bias. So here's a rough definition. It's a tendency to interpret outcomes of others' actions as intentional, okay, when they have a negative result, as opposed to when they have a positive or neutral result. Or it's a tendency to interpret ambiguous situations as the result of someone else's intentional aggression, as opposed to an accident. So roughly, it's a bias towards thinking that people are more jerks than they really are. I mean, that's, if you had to sort of summarize it in one nutshell, that would be it. So here's a study. So people were asked, they were given this passage to read, and then they were asked a question. So first let's read the passage, and then I will ask you the question that the subjects were asked. Okay, so here's what subjects were told. The CEO of a company is sitting in his office when the vice president of research and development comes in and says, "We're thinking of starting a new program. It will help us increase profits, and it will also harm the environment." The CEO responds that he doesn't care about harming the environment. He just wants to make as much profit as possible. The program is carried out, profits are made, and the environment is harmed. Okay, here's the question. Did the CEO intentionally harm the environment? Okay. Turns out, well, actually, a different group of people was given a different version of that same story, but with just one minor change. So here's the story the other group was given. The CEO of a company is sitting in his office when his vice president of research and development comes in and says, "We're thinking of starting a new program. It will help us increase profits, and it will also help the environment." The CEO responds that he doesn't care about helping the environment and just wants to make as much profit as possible. The program is carried out, profits are made, and the environment is helped. So you see the two stories are identical, except that in the first version, the side effect is that the environment is harmed. In the second version, the side effect is that the environment is helped. And in the second version, subjects are asked, did the CEO intentionally help the environment? Okay. Now what the finding is that in the first version, where the CEO says, look, I don't care about whether the environment's harmed, I just want to make profits. And the policy is implemented and the environment's harmed. 80% of the people said that the CEO intentionally harmed the environment. In the second version, though, when you asked, did the CEO intentionally help the environment, 80% of the people said no. So the only difference was the outcome good or bad? Was the outcome, the side effect, positive or negative? If it was a negative effect, people were much more likely to say that it was intentional. The CEO intentionally harmed the environment. When it was a positive effect, only 20% of the people said that the CEO intentionally helped the environment. Okay. So here's another example. So that's the Nobe effect. And this, by the way, the Nobe effect, which is what I just talked about up here, this has been replicated in a lot of different versions of it that control for various things. Well, if you're interested, just do a Google search for Nobe effect. But there's been a lot of different versions of this story that control for different possible factors. Okay. Here's another study. So you had pairs of subjects, and it was either men or 2 men or 2 women or whatever, and they were competing in a block building task, right? So you'd be sitting at a table, and you were shown there were blocks on the table, and there was a picture, and you had to sort of build something that looked like the picture out of the blocks or something like that. And at various points, subjects would leave the room or come back, or they would turn around or whatever, and the blocks would fall over. If I remember correctly, I think that maybe the 2 people building, the subject was told that they were both subjects, but actually the other person wasn't really a subject. They were actually part of the study. So it was really only one person being studied. But they thought it was just, okay, we're 2 subjects who've come in here. And when the person would come back and see that their blocks were knocked over, they would be asked, or they would just be assessed whether they thought that, oh, this other person knocked my blocks over because they're a jerk, or, oh, my blocks probably just accidentally fell over while I was gone because the table shifted or something. And what they found was that aggressive subjects, so there was a separate assessment of aggression beforehand, like psychological studies that just sort of showed how aggressive these people happen to be. Aggressive subjects were much more likely to attribute misfortune, like the fact that these blocks were fallen over, to hostile behavior of their peers than were the non-aggressive subjects. So the more aggressive someone was, the more likely they were to interpret other people as being aggressive. This actually resonates with my own experience. When I was a kid, I would play a lot of games, and the people who were actually most likely to cheat were the ones who also thought other people were cheating all the time, or would always accuse other people of cheating. So there's some real world manifestations of this effect. One is road rage. So people who, when people are driving, there's a lot of things that can happen, and sometimes, you do things either on accident or possibly on purpose that are dangerous or irritating to other drivers. Maybe you're driving really fast just because you're a generally reckless person, you don't care about safety. Maybe you're driving really fast because you have a friend or a spouse in the car who has to get to the hospital because they're seriously injured, right? But people tend to interpret what they view as driving that might be dangerous as intentionally reckless more often than it really is. People get really pissed off at that driving. This falls under the heading of ambiguous events, right? So if someone leaves a room and the door slams pretty loudly, well, it's ambiguous in the following sense. Maybe the person was really mad when they left and they just slammed the door because they're pissed off at everybody. But sometimes people just misjudge how easily a door swings, right? They think that the door has like an automatic damper on it that sort of like will make it close slowly. And so you have to put a little more muscle into the door to get it to close. But really it doesn't have that. And so the door accidentally slams. So it's an ambiguous situation. People are much more likely to interpret it as a manifestation of an aggressive intention than they are. Another example is whispering. So this is an example that's used in a lot of these studies where there will be, you'll have a subject who's doing something and there'll be two other people nearby who are whispering. And then the question is, are they whispering about you? Are they like saying something negative or disrespectful or whatever about you? Or maybe they're just whispering about, they don't even know you're there. They're just like talking about some other topic. And people are more likely to interpret it as actually being directed at them than in a negative way than it is. It also shows up in interpreting political policies. So especially with extreme views, if a policy gets implemented that might have some negative effects, people are much more likely to attribute that to purposeful negative intentions on the parts of the political people who implement those policies. Anyway, that's about it. And done with this.